This video is about complex systems research. If you are doing complex systems research or you're talking about or using the worldview of complexity or complex systems, then you are in the right place because this video is about the theoretical and practical implications. This resource by Preiser or Rika Preiser from 2019 will definitely help you. It's called Identifying General Trends and Patterns in Complex Systems Research, an overview of theoretical and practical implications, which was published in Systems Research and Behavioral Science, and I put the DOI number, which I believe is available online. So the use of complexity and complex systems as concepts, just so you know, have increased recently in research studies. If you are one of these people looking at this video, you would be probably conducting complex systems research. But there is no agreement. Preiser argues that there is no agreement on when the theory came about. And because of that, there is no unifying theory of complexity to expect. Instead, we should be speaking of what she calls theories of complexity that come from different disciplines, so different conceptual origins. And because of these differences in theories, it is often the case we see terms like complexity science being used interchangeably with complexity theory, complex adaptive systems, and just the word complexity, which I've personally also experienced when I was doing my research, my PhD. Preiser also argued that there is no single agreed upon definition of the meaning of the word complexity in the literature. So upfront, this is very useful to know about complexity theory, its origins, and how these origins are complex, and that there are theories of complexity rather than one theory, and these stem from different disciplines. There are definitions of complexity out there, but Preiser found the following definition to be most useful in terms of understanding what it means, and it was this definition is from a complexity economist called Brian Arthur, 1999, and he defined or looked at complexity as common to all studies on complexity are systems with multiple elements adapting or reacting to the pattern these elements create. It is important to note that although there is no currently unifying theory of complexity, common theoretical and practical principles do exist to inform studies, or one of them could be your study, underlined by complexity notions. So common to complex theory is studying systemic phenomenon where you will come across concepts like nonlinearity, self-organization, and emergent behavior are seen as dominant qualities. On the other hand, our uncertainty in behavior comes from responding to external influences and outside shocks. Acknowledging complexity of phenomena signals a shift in paradigm where organization and relationships are favored over static structures and entities, respectively. Preiser developed 6 principles or common properties of complex systems, and these she discussed under page 708. First principle is that which you should be aware of if you are doing any research related to complex systems, complexity, complex adaptive systems, or have got, doing research with a where your worldview is underlined by complexity. So the first principle to be aware of is that complexity of problems, issues, or phenomena that you are concerned with, that you are studying, are concerned with relationships because behavior and structures emerge from patterns of the relations that exist between system components. Second principle is that complex systems can adapt by self-organization and by, co-evolving. The third principle is that the dynamic relations that characterize complex systems are nonlinear. So you are looking at two factors with an input and an output. The relationship between these two factors won't be uniform or proportional. The fourth principle that you should be aware of is that complex systems are context dependent, which means if you change the context, then this will have an impact on how a system functions. And importantly, the descriptions we put to complex systems and say how they behave will depend on, in this case, on the analysis level that we do and undertake to understand the system. The fifth principle is that we have to think about complex systems as open, which means we can't specify the boundary line between the system and its environment. This is very important, and this because this very environment plays a role in the system's complexity. So putting a boundary is a product of physical properties and our mental doing, where we choose to draw a line between a system and its environment. And the final principle, the sixth principle, is that emergent phenomena happen as a result of complex causality, which is the outcome of circular, interrelational, nonlinear, and dynamic interactions. These cause different observed consequences that are different from what we know about the constituent elements of a system. Now, Preiser also argued under page 711 of her article is that studying and understanding the features and dynamics of complex systems when we encounter complexity needs and requires a shift in how we understand the nature of reality itself. So this is very important if you are doing research involving complex systems. Any engagement with complexity requires methods of inquiry and knowledge, creation, practices, or analysis, if you like, which draw from a plurality of epistemologies or positions, ontologies, for engaging interdisciplinary and transdisciplinary teamwork to find sustainable solutions to complex problems. So in order to create useful models of complex systems, Preiser argues that we should forget traditional scientific methods that are aimed at prediction and control of the system under study. And it's unfortunately often the case that I hear people saying, what do you predict? What's your solution when you are studying or discussing complex research or research that is underlined by complex issues and complex phenomena? Because they just do not understand that with complexity comes different ways and a need to look at complexity and appreciate the behavior, the emergent phenomena that comes with it, the nonlinearity, and all these things. So it's not a matter of predicting and controlling what we have, which is often seen in traditional scientific methods. Preiser also included a set of heuristics, what they call, that would help you and as a researcher and to help practitioners engaged with complexity in ways that are mindful of complex systems principles. These include adopting an interconnected way of thinking about the nature of the problem that you are having to deal with, and the world where assumptions based on control and demand based planning and decision-making approaches get challenged with systemic, context-sensitive, emergent, and episodic assumptions. Secondly, identifying system characteristics, including key variables, parts, and interconnected processes, which ultimately influence emergent behaviors of the system. And third, facilitate personal and institutional capacities to handle complex systems, both personal and institutional, through reflections, learnings, and actions. So hopefully these heuristics will help you to know how to engage with complexity.